Welcome to next lecture in Engineering Mathematics 2. So in this lecture, we shall see a few examples on gradient of the scalar point function f, that is del f. So please stay tuned with this video lecture as we have solved around 3 problems of different types to explain you about the gradient of the scalar point function f. Before we begin with this video lecture, I request you to please subscribe to this YouTube channel if you have not yet subscribed. Please click the bell icon for the latest notifications of the videos on this channel. Follow us on Twitter, Instagram, and like our Facebook page, Mechanical Engineering Tutorials. The links are in the description below. So friends, let's begin with the lecture.
In today's class, we'll solve examples on gradient of a scalar point function. So if f is a scalar function, we have learnt that del f is a vector quantity which is normal to the surface. So the first example on this, find the angle between the surfaces x square plus y square plus z square is equal to 9 and z is equal to x square plus y square minus 3 at the point 2, -1, 2. Friends, here two surfaces are given and a common point is there, and we have to find the normal to the first surface at this point and normal to the second surface at this point, and angle between two normals to these two surfaces is defined as angle between two surfaces. So let us denote the first surface as f1, x square plus y square plus z square minus 9, and f2 the second surface x square plus y square minus z minus 3, means all terms are collected on one side. It is a very simple problem. Then del f1 formula, you all know, it is I into dou f1 by dou x. Directly I have substituted for f1. So what do you get? X square plus y square plus z square minus 9 plus j into dou upon dou y of f1 plus k into dou by dou z of the value of f1. Partial derivative, that's equal to first term, it is only 2x, all other terms are constants. Next, j into it is 2y and k into it is 2z. So we got del f1. Now calculate del f1 at the given point 2, -1, 2. So in place of x, y, z, substitute the x coordinate, y coordinate and z coordinate. So you get 4i minus 2j plus 4k, and let us call it as n1 bar. Next we shall consider f2. So del f2, directly I have written I into partial derivative of f2 with respect to x is 2x, with respect to y is 2y, with respect to k it is -1. So calculate the value of del f2 at the same point 2, -1, 2. So del f2 at 2, -1, 2 will give us 4i minus 2j minus k, call it as n2 bar. Now it is sufficient to find the angle between the two normals, that is n1 bar and n2 bar. So I have written the definition here. Since the angle theta between the two surfaces at a point is the angle between their normals at that point, and n1 bar and n2 bar are normals at 2, minus 1, 2 to the given surfaces. Friends, we all know that angle between two vectors a bar and b bar, cosine of the angle between the two vectors is cos theta is equal to a bar dot b bar upon magnitude of a bar upon magnitude of b bar. So that formula is being used here. So cos theta is equal to n1 bar dot n2 bar upon magnitude of n1 bar into magnitude of n2 bar. So that's equal to, substitute for n1, it is 4i minus 2j plus 4k dot 4i minus 2j minus k. Denominator, magnitude of the first vector, it is 16 plus 4 plus 16 into, here it is magnitude is 16 plus 4 plus 1. Thus dot product you all know how to find. 4 into 4 16, minus 2 into minus 2 plus 4, 4 into minus 1 minus 4 upon this becomes 16 plus 16 32 plus 4 36, root 36 is 6 and here it is root 21. Cancel 4 and minus 4, cancel common factor 2. So 8 upon 3 root 21 is the value of cos theta. From that you can find the value of theta, that is cos inverse of 8 upon 3 root 21. So this is the angle between the two surfaces. Example number 2. Find the values of a and b such that the surfaces ax square minus byz is equal to a plus 2 into x and 4x square plus 4x square y plus z cube is equal to 4 cut orthogonally at 1 minus 1 2. So here the given condition is these two surfaces are orthogonal surfaces, means the normals to these surfaces at this point are perpendicular to each other. And friends, do you all remember what is the condition for two vectors to be perpendicular? Their dot product is equal to 0. So we have to use that condition and find unknowns a and b which are there in these equations. Denote the two surfaces as f1 and f2. So f1 is ax square minus byz. Collect all terms on one side. Minus of a plus 2 into x is equal to 0. f2 4x square y plus z cube minus 4 is equal to 0. Del f1 I into, formula for del f1 is I into dou f1 upon dou x, j into dou f1 upon dou y plus k into dou f1 upon dou z. So I into f1 with respect to x is 2ax, then here minus a plus 2 into derivative of x becomes 1, so I have opened up the bracket, minus a minus 2 plus j into f1 with respect to y minus bz I have written plus k into dou f1 by dou z. Dou z means here only you get minus by. These two will become 0. So del f1 at the given point 1 minus 1 2 is equal to I into bracket, when you substitute x y z as 1 minus 1 2, it is 2a minus a minus 2. Here z is 2, so minus 2bj plus here k into y is minus 1, so it becomes plus bk. Call it as n1 bar. n1 bar is what? Normal to the surface f1 is equal to 0. Just remember that. Same procedure is to be followed for f2. Del f2 formula I dou f2 upon dou x, j dou f2 upon dou y, k dou f2 upon dou z. I with f2 with respect to x, 8xy, then j into with respect to y is 4x square plus k into 3z square. Del f2 at 1 minus 1, 2 you calculate, that's equal to, it is 1 into minus 1 means minus 8i. Then 1 square is 1, so plus 4j plus k into 3z square, so 12k. Call it as n2 bar. So you have n1 bar and n2 bar. Now given condition, they are orthogonal, means they are perpendicular. So I have written here the surfaces f1 is equal to 0 and f2 is equal to 0 will cut orthogonally if n1 bar dot n2 bar is equal to 0. So n1 bar, substitute a minus 2 into I minus 2bj plus bk dot minus 8i plus 4j plus 12k. This is equal to 0. Dot product means what? Corresponding coefficients of I, j, k are multiplied and added. So it is minus 8 into a minus 2 minus 8b plus 12b is equal to 0. Simplifying, minus 8a plus 16, here 12b minus 8b can be combined, plus 4b is equal to 0, or cancel common factor 4 throughout, minus 2a plus b plus 4 is equal to 0. Call it as equation 1. This is one equation involving unknowns a and b. Also, the point 1 minus 1 0 lies on the two surfaces. So I will consider that it lies on f1. Both are correct, but let us consider that the point 1 minus 1 2 is on f1. So wherever x, y, z are there, here substitute 1 minus 1 2. Friends, here I took f1 because there are unknowns in this equation. In f2 also you can substitute and check. This coordinate will satisfy this equation. When you substitute for x, y, z, these values, you should get right hand side value. So what we get here, a into 1, then here y and z are minus 2, so it becomes plus 2b. Here x is 1, so minus a minus 2 is equal to 0. A and minus a cancel. 2b minus 2 is equal to 0, so 2b is 2. Thus you get an unknown value b equal to 1. Substitute this in 1, so minus 2a plus b, it is 1 plus 4 is equal to 0. Thus a is equal to, we get 5 upon 2. Therefore a is 5 upon 2 and b is 1. This is the final answer. Friends, now let us see one more example on this. Find the angle between the normals to the surface xy is equal to z square at the points 4, 1, 2 and 3, 3, minus 3. Friends, here just see carefully. This equation is altogether different. This problem is altogether different from previous two. Surface is only one. So there are different points are considered on the same surface and normals are drawn at these points, and then you have to find angle between the two normals. Of course, procedure is almost same. Let f be the given surface xy minus z square is equal to 0. Del f formula I dou f upon dou x plus j dou f upon dou y plus k dou f upon dou z. So that's equal to I cap into dou f upon dou x is y, j dou f upon dou y is x plus k, it is minus 2z. Now you have to calculate this del f at these 2 points separately. Del f at 4, 1, 2 will give you I plus 4j minus 4k, call it as n1 bar, and at second point 3, 3 minus 3, it will give 3i plus 3j plus 6k. You can substitute and check and denote them as n1 bar and n2 bar. Now lastly, just you have to find angle between the two vectors here, these two normals. Therefore, angle between two normals n1 bar and n2 bar is given by same formula, cos theta is equal to n1 bar dot n2 bar upon magnitude of n1 bar into magnitude of n2 bar. Substitute the values here. So n1 bar is I plus 4j minus 4k dot n2 bar is 3i plus 3j plus 6k divided by root of 1 plus 16 plus 16, and here it is 9 root of 9 plus 9 plus 36. So dot product, it is 1 into 3 plus 4 into 3, 12 minus 4 into plus 6 minus 24 divided by root 33 and here root 54. So here 15 minus 24 is minus 9. See, root 33 is written as root 3 into root 11. Then here 9 into 6, 9 you take out, 3 root 6. So minus 9 upon root 11, root 3, 3 kept as it is, root 6 is written as root 2, root 3. Root 3 into root 3 is 3 into 3, 9. So 1, 2, 3 is cancelled with 9. What you get is minus 1 upon root 11 into root 2 is root 22. Therefore, theta is equal to, you get cos inverse of minus 1 upon root 22. Friends, these are the examples on normal to the vector, that is gradient of a scalar point function. Here I have given one example as a home assignment. Find the values of a and b so that the surface is 5x square minus 2yz minus 9z is equal to 0. May cut the surface ax square plus by cube is equal to 4 orthogonally at 1 minus 1 2. Now this problem is exactly similar to the second sum. Just solve this, and answer also I have given. A is equal to minus 6 and b is equal to minus 10. Thank you.